All right, let's talk about the OG element, the very first one. Today, we're diving into hydrogen, the simplest and by far the most common element in the whole universe.
I mean, think about that for a second. This one element makes up like 3/4 of all the regular matter out there in the cosmos. But here on our own little chart, the periodic table, it's a total loner. It just doesn't seem to belong anywhere. And that is where our story really kicks off.
If you pull up a periodic table, you'll probably see hydrogen, element number 1, sitting right on top of group 1 with the alkali metals. But sometimes you'll see it just floating there, all by itself. Or, get this, sometimes it's even placed all the way over in group 17 with the halogens. It's wild. Chemists have literally been arguing about where to put this thing for more than 100 years. And why? Well, because hydrogen is a bit of a rebel.
Okay, so let's get into it. Why exactly is hydrogen the periodic table's ultimate loner? It all comes down to its structure, which is super, super simple, but also totally unique.
And that structure, it gives hydrogen this dual personality. It's the root of its whole identity crisis. It can behave like two completely different kinds of elements. It really just depends on the situation.
So check this out. On one hand, hydrogen has just one little electron in its outer shell. It can lose that electron pretty easily, which forms a positive ion. That's exactly what the alkali metals in group 1 do. But here's the flip side. It only needs one more electron to have a full shell, so it can also gain an electron, forming a negative ion, which is exactly what the halogens in group 17 do. It can give or it can take. It plays both sides.
And you see this two-faced behavior in its actual chemistry. Like sodium, which is an alkali metal, hydrogen can be a great reducing agent. But then, just like chlorine, a halogen, it loves to pair up with another hydrogen atom to form a molecule. This is the hard evidence, and it's why the debate is still going on. It really does have a foot in two completely different chemical worlds. Okay, so hydrogen is one of a kind, we get that. But how do we actually, get it? I mean, it's everywhere in the universe, but here on Earth, it's almost always locked up in things like water. You almost never find it just floating around as a free gas. So the first challenge is just prying it loose. And that's the big question, right? If we're going to use hydrogen for anything, we've got to figure out how to break it out of the compounds that's trapped inside. Well, one of the classic ways to do it in a lab is basically a chemical switcheroo. You take a metal that's more reactive than hydrogen, you drop it into some acid, and bam! The metal literally kicks the hydrogen out, takes its place, and sets the hydrogen free as a gas. The reason this works is because of something chemists call the activity series. You can think of it like a power ranking for elements. And if you look at the list, any metal above hydrogen, we're talking zinc, iron, magnesium, is strong enough to do the job. But anything below it, like copper, nope, not going to happen. It's a super simple but really powerful way to predict what's going to work. All right, so we know how to set it free. Now for the fun part. What can we actually do with it? Because hydrogen isn't just some weirdo on the periodic table. Once you isolate it, it has some pretty incredible real-world superpowers. I mean, the versatility is just amazing. It's a super clean fuel. When you burn it, you just get water. It's also lighter than air, which is why it was used in things like weather balloons and in industry. Oh, it's a workhorse. It's used to turn vegetable oils into margarine, to make fertilizers for our food, and to create the super hot flames you need for welding and cutting metal. And you know what's really cool? There's a classic test for it in the lab. If you think you've made hydrogen, you just take a lit match or splint and put it near the opening of the test tube. If it's there, you get this really satisfying sharp pop sound. It's basically a tiny explosion as the hydrogen and oxygen react. That pop, that's hydrogen's signature move.
So all these things, right, the clean fuel, the industrial uses, it all points back to hydrogen's true identity. When you strip everything else away, its most fundamental job, its core purpose, is to be a powerful agent of chemical change.
And to really get a handle on that, we need to talk about one key idea: reduction. Now, I know reduction sounds like something is getting smaller, but in chemistry, it means an atom is gaining electrons. And this is hydrogen's superpower. It is a fantastic reducing agent. It's just so generous with its one little electron. It's always looking to give it away, which makes it the ultimate electron donor. It hands off its electron, and in doing so, it reduces whatever it reacts with. Okay, check out this example. You start with this black powder, copper oxide. Then you pass some hydrogen gas over it. What happens is amazing. The hydrogen just swoops in, grabs the oxygen right off the copper, and forms water. As it does that, it gives its electrons to the copper, transforming it from a black powder back into pure reddish-brown copper metal. It's incredible. Hydrogen is a master of transformation.
So when you think about it, from its weird, lonely spot on the periodic table to its power to fuel rockets and completely transform other elements, hydrogen is anything but simple. And it really makes you wonder, right? As we're all looking for cleaner fuels and better materials, what other incredible transformations could this little powerhouse element make possible for us next?